start introducing ourselves. I'm Samantha Sager. I'm a QA analyst in your modern.
James Sopranos. I'm the development manager for the Trogdor team, which is partially in front of you here, and I've been an engineer working in JavaScript for about 3 years now, and in microservices for the last couple of years, and doing lots of research and pushing that forward as an option for our company.
That's me, Stephen Buchholz. I've been developing software since sometime in the 1980s. Yikes. Starting with COBOL.
Did you do microservices in COBOL?
No. COBOL, Fortran, anybody remember Ada? You probably, yeah. And I've been at Accusoft for 10 or 11 years. Most of my time spent in our low-level C code and our software imaging development kits. And only in the last year or so have I learned, current stuff like JavaScript and Node.js, and so that's what I'm doing now.
What, no experience with BASIC though?
Basic. I avoided that one.
And yet I didn't.
I'm Mike Irigoyen. I have been working with Accusoft for a little over a year, and my experience with microservices matches that time. Although I have been working in JavaScript for about 10 years, Node.js for about a year, and microservices for about a year as well.
Hi, I'm Joe Cariotti. I've been at Accusoft for a little over 3 years now, and I originally started in the low level, the weeds there with that stuff, and more recently moved to the SaaS group and started working on web-based technologies. So again, I don't have quite as much experience as the rest of these guys over here, but for the past year or so, I've been right with them and working in microservices, Node.js, all the most recent technologies. So.
Right, so maybe we should start out with just talking about what a microservice is.
You want to go first, or is this one?
Go ahead, James.
Go ahead. So microservice architecture is sort of the latest buzzword. If you ask, including the people who wrote the book, defining it is difficult. It's really a methodology that came around. People were already doing it. They decided to ascribe a name to it. So they got, people got together, companies started talking, and realized they all had a similar set of patterns. We wanted reusable pieces of code. We wanted modular architectures. We wanted small, separate running processes that could be independently deployed. And actually, Ronnie Mitra, who kind of wrote the book on microservices, actually has a matrix of, I think it's 6 by 6. So I guess 36 different keywords that describe what a microservice is. And basically says you pick anywhere from 2 to 36 of those for your company and decide that's what we're going to call microservices. And that's what it is. So it's really the ability to run smaller pieces of code and have them talk over some sort of protocol.
What was the name of the author you just mentioned?
Ronnie Mitra.
Ronnie?
Mitra, M-I-T-R-A, at CA Technologies. Which you currently have the book in your bag for, I believe.
Which one is that? Oh, this one?
Yes.
This one?
That one.
Microservice architecture. Yes, this is a good book. You can actually get it for free, the electronic version. Microservice architecture.
Yeah.
Aligning principles, practice, and culture. I have nothing to do with the book, other than I've read it, it's pretty good.
But and it's free, so even if we had something to do with it, we get a cut of the free.
But I have a piggyback on that. So if you think about it, those of you who have been around for a long time, if you have a large system, we've always had ways of decomposing that into smaller components, right? This is a book from 1988 that I took, Strategies for Real-Time System Specification. And here's some architecture diagram where they've decomposed a system into what they call then subsystems, right? This is some aircraft control system, guidance subsystem, navigation subsystem, control subsystem. So it's decomposing it, right? This is a really interesting one. This is 1994. This is Canadian air traffic control system that I worked on. They were redesigning their whole air traffic control system. Again, this was in Ada, but they decomposed the system into subsystems. A subsystem is a program library that groups a set of closely related objects. Workspace for a small team of developers. In microservices, we put a small team of developers on each microservice. They're an independent team. Those developers can develop code protected from other development taking place in parallel. We develop our microsystems in parallel. We have lots of small teams. Subsystem is the focus of software configuration management. Well, we have our subsystems. Each one today has its own Git repository for configuration management. This is interesting from 1994. It is the smallest unit of release. We talk about being able to independently build, test, and release a microservice. And they were talking about here being able to independently release and test these subsystems. So certainly microservices has some new things I think they've been added to the concept. But sort of that concept of decomposing a system into smaller logical pieces goes back a long way.
Well, what it comes down to is something that obviously we've been doing for a long time. I come from a PHP background where it was a lot of object-oriented, and that's what you're doing there too. You're splitting those objects in pieces, like fundamental pieces into objects which do one thing. You have an object for users, and you have an object for organizations. And now we're just taking that to an extended level where we're running just the user section on a server by itself, that all it does is deal with servers, and if it goes down, it's not going to take the rest of the system down with it. Or if it needs to scale, it can scale independently while everything else stays the same.
All good?
Oh, yeah. I don't want to spoil one of the future questions.
There you go.
Yeah.
All right, so we had a couple people inquire about sizes of microservices. So how small is too small for a microservice? And Jacob asked, how do you determine the correct size for a microservice?
Well, start with that on this time.
Sure, and I think, Stephen, you hit on this by saying that the size of the microservice really is determined by the functionality that goes into it. So it should be a lot of closely related either objects or functionality. So whether that functionality is large or pretty small, like something simple like an email sender, email gateway, what should really go into a microservice is common functionality. I think one of the things that we discussed is that sometimes you start lumping too much common functionality together and you need to decompose it more. We have a microservice right now that's pretty large. We went to refactor it. We don't like the way it looks. It's huge. No one wants to touch it. And we realized that it's something that we could probably split into a couple smaller microservices. And not because of the size of it, but more so that we could find ways to cut it into more specific sets of functionality.
I mean, at this point in time, especially with AWS and the cloud and Docker images, microservices, they're inexpensive. They don't take a lot of resources, so having a single microservice that does a very small amount of data is not going to be negative to your product. At least it shouldn't be. So there is no too small in that case. I would argue there's too big, but definitely not too small.
So we're having a discussion in the team about this right now, about breaking this one microservice we have that's fairly large into maybe some more. Mm-hmm. And I might argue there's nothing too small, because what you don't want, one thing all the books talk about is too much coupling between microservices. The whole classic thing, you want a microservice within itself to be cohesive. Everything is related to each other. It all sticks together. But you don't want too much coupling between microservices, because if you have too much communication going on between the two, if you have one microservice that depends on this other one too much, and this other one then depends on that other one, you have a lot of back and forth. And you might think, well, do those things really deserve to be separated? Are they really closely related? And so maybe your microservice needs to be bigger than you feel that it should be, because those things make sense together. And there's a trade-off and there's a balance to be had there, and you have to find that. And there may not be any exact right answer, but those are things to think about when you decide about breaking something apart that feels too good. It feels too big. And just to quote this book again, not to plug it. There's no simple universal measure for determining just how small a microservice should be, e.g. quantity. What people tell us that they use the word small, they use it as a quality, like reliable or coherent. So there's no cookbook answer. It should only have these many lines of codes or these many functions. So it's an analysis, and it's an iterative analysis, I feel.
Until you find somebody who tells you it can't be more than this many lines of code. Yeah. So out in the audience, who's aware of the website and app Gilt, G-I-L-T? for purchasing high-end products online, whatever. So Gilt, they're big proponents of the microservice architecture, and they have broken down their application to the point where every single page that you could go to on Gilt, each web page, each component of the web page is a separate microservice. So if there's a bar on the right that talks about a sale they're having, there's a team that owns that microservice, and that microservice runs independently of everything else in the system. We're doing a lot of research into how to split up microservices on the UI right now, because that's kind of a point of contention, because the UI is inherently coupled. You want similar look and feel to all your UIs, that sort of thing. And it ranges all the way from the Gilt side of things, of every single thing that happens should be its own microservice, up to lots of other large companies who say, we have 500 microservices on the back end, and our UI is one piece. Because they consider the UI a single component that consumes all those microservices. And so, I mean, that says there's not a lot of consensus in the field about how big something should be. I think Stephen touched on a really good point, which is that level of dependency. If you can't if you want to take something and break it into 4 microservices, and then you can't honestly say each one of those 4 things, if one of them fails, the rest of them can continue working, then you haven't really broken it. You've just kind of taken your microservice and run it as 4 processes now. You still have this tightly coupled 4 things that have to run at the same time, and if one of them goes down, everything fails. You want one-way dependency, and you want very strict lines of what they're doing. If there's a lot of crossover and there's a lot of, A calls B calls A calls B, then there's really first of all, there's no valid way to break it down that's not going to end up with lots of dependency anyway. And the whole point of microservices is one of them can go down, can be deployed separately, and if that's not the case, then you're not really saving yourself.
Right, and so those 4 things, can you deploy one of those separately? Or are they so tightly coupled that if you make a change to one, well, that ripples across all the other 3, so you have to deploy all 4? Well, that's not ideal either, right? But
I think you bring up a good point about error handling. I believe it's Netflix that actually wrote a program to go around and just destroy servers, destroy your microservices.
Yes.
And it brings it down, and then I think they usually do it while they're working, and then they can analyze and say everything recovered properly. Our error handling worked well. Users weren't affected. We were able to easily spin up a new microservice and deploy it on the fly, and there were no interruptions, no downtime, anything like that.
Netflix is all about their simian army. So they have Chaos Monkey, Chaos Gorilla, Chaos Kong.
That's right.
And then they're great things. But Chaos Monkey specifically is the one at the microservice level.
Yeah.
Great, so how do you decide on a microservice architecture for a particular project?
So for what we've done recently, we pretty much start with the concept that everything we do is going to be built in microservices, mostly due to the fact that it allows for sharing code. We have, at our company, 3 major product divisions who overlap a lot on the work we do. Not actually the code we write, but the end result of that thing. So we have a library that gets written in C++ that then gets consumed by an API and then exposed, and then our web products use that API to get work done. And by building everything as microservices and using a standard methodology for how they're going to communicate, we can take a microservice written by one team that had no intention of this thing ever being on the web. It was a for sale on-prem product, and we changed the config file and we put it on a web server, and now it's part of our cloud offerings. Or we put it inside one of our consumer applications and deploy it on the cloud, and it becomes part of one of our consumer applications. And so we kind of build everything with the idea of microservices, specifically for interoperability and the ability to change things going forward and not have to worry about one team over here made a decision that now means we can't use it on the other side of the house. And so because of that, we kind of build everything with that first.
is that question, I hope, is the person in here, is that about how do you decompose a system into microservices? How do you come up with what your microservices should be? I don't, am I reading that question wrong? I don't know.
Read it again.
How do you decide on a microservice architecture for a particular project?
Or is it more? Because that's another aspect. You have a big system, and how do you decompose it, right? So that's a lot of it is domain analysis, domain-driven design, which is a thing, right? You just have to think, what are the logical entities in this system? Let's say we're designing a system to automate business processes and workflows, and these business processes can do many things. Like inside of a business process, it could send an email to something, it could send a document to an external system, it could redact hidden things in a document, Well, right there, those are three separate domains. Sending an email is an entity that might be a microservice. Sending a document to some external system, that's an entity that can live by itself. There's a microservice. Or some sort of image processing, document processing like redaction, that might be a first level decomposition.
And maybe if I'm building an application where it's small enough to where I don't want to have to deal with the overhead of building a microservice framework, or if I'm not ever planning on deploying one piece of it without deploying the entire thing, if it's an installable executable where you're always going to package it as one file at the end, that might not necessarily need to be a microservice architecture application. If it's maybe too small to be broken down or not worth the effort or the overhead of breaking it down. So there's a lot of overhead with microservices. Communication in between the microservices.
A lot of duplication.
Docker images, lots of Docker images.
You mentioned a lot of overhead. So do you do a lot of overhead versus performance trade-offs, or does that really, based on the fact that a lot of machines are fast now, a lot of memory, multi-core, is the performance versus function trade-off really not relevant anymore?
I think that's pretty true.
Yeah, we did, we actually just had this discussion a week ago when I wrote a quick benchmark up that took one of our microservices that processed a large document and took the request and funneled it through two other dummy microservices that just took the document and piped the request to the other one and did some benchmarks to see out over 1,000 requests, how much impact is adding two null microservices in front, and it was, within the margin of error. We were able to run the test multiple times, and if you covered up the labels, you couldn't tell which one was with the extra microservice and which one wasn't. So it's pretty negligible. It was on the order of 20 milliseconds difference in time on 1,000 iterations. So
it also depends on if you're storing your microservices on different servers or on the same server within different Docker
correct.
images.
So that was microservices running in the same machine and talking over local TCP ports, not cross network. That would definitely have more latency.
So how do you handle communication between microservices?
Just like that.
Do you have anything to add?
No? We communicate basically via REST. So we use the CRUD layer for all of our communication between microservices. I know that there's other ways of doing it, but since I've only worked with microservices for about a year, we use REST for everything, and it makes things easier because REST has been around forever. Everything we do is that way, so it's standardized. We know what to expect when we build a microservice. We know we're going to build it listening on certain endpoints, and we know we're going to return information in a certain way. So that way we can assume every microservice that we communicate within our company is going to interact in those same ways, and it just makes it more reliable and yeah.
I can add to that. Okay, so so we use JSON and REST for most of our stuff. Some of the other common ways to interact with things are via some sort of message pipeline or message queue, so that you have instead of a direct communication model, you have like a pub sub model for message handling. There's some pros and cons of both of those. Waiting for responses on the message queue is more difficult. Propagating something to a lot of endpoints is more difficult with the REST model. But the general idea is to keep something consistent, look at how you want to use your microservices. One of the reasons we settled on REST and using that is that's the common sort of outbound mechanism. When you have an API, something on the web, in which we have lots of cloud APIs, that's what people expect. They don't expect some sort of proprietary communication protocol to talk to your web service. They expect, I post here, I put here, and I get this response back, and so internally we follow that same thing. So then we have a web endpoint and a customer says, I love the product, but I'd love to be able to manually upload this. We can say, okay, here, expose that publicly. Now you have, add authentication in front of it, and now you have a RESTful layer to do it. And we don't have to write some sort of connector to say, well, on the inside we use this message queue, and so we need to now make a new front end that takes this put request and translates that into what goes into the message queue. So we just decided that for simplicity, we'd like to be able to use externally and internally RESTful communication.
So we could expand a little bit on those.
Let's go to the whiteboard.
This is something that be coming up for us? Let's say these are a bunch of microservices. Let's say this system has users that can come and go. And when the user is created, various entities might be created in these microservices. Now that user gets deleted from the system. He's gone, he removes his account, whatever. Each one of these microservices might have something that has to be deleted for that user. Some email information, some workflow information, some document information. They all have stuff related to that user. So coming into maybe some gateway type of microservice is a request to delete the user. So one way of thinking this, using the whole sort of REST idea that we have in place, is that maybe this gateway has to know that, oh, we're deleting the user, so this guy has to know about it because he has to delete emails for that user. This guy has to know about it because he has to delete documents for that user. This guy has to know about it because he has to delete something else. That's one of them. He mentioned this pub sub thing. Imagine a sort of different scenario. Let's call this a notification hub. Let's say we have these same 3 microservices. This handles, if you've done any mobile programming, you know that there's an event distribution mechanism in iOS and Android where some event happens in the system and different components can register to be notified of that event. Say there's an event defined in the system that says a user has been deleted. So this guy publishes that event has happened. These people, these microservices, when they start up, have subscribed to this event. Whenever somebody is deleted, tell me. And so they get notified. So this makes it sort of a more generic mechanism. So that's kind of 2 ways of doing it. I think the key is, if you start to mix these things, you might run into some issues.
It's very messy.
It can get messy. But, some questions.
So in the notification hub scenario, how do you handle a response back to the gateway service confirming deletion?
I don't know.
So a common one we used
that one.
on the client side for a message queue system, we had a system we were building, and the way we handled that was we didn't do direct responses. We did indirect by way of when you publish something you either publish an action or a status. So in other words, the top one would publish delete user, and then the metadata user number 52. And then later on, the rest of them would respond was with user emails deleted for user 52. So in other words, one thing would publish in do this, and the other ones would publish in I did this. And so something else could listen. That top one could listen if it needed to. If it actually cares that everything was cleaned up, it can say publish delete user, and then on user emails deleted, user data deleted, user history deleted, whatever. Once I've gotten all those, I can return back to the user. If it doesn't care, or maybe it listens for all those, and if something doesn't happen, it logs in an error log somewhere, tells somebody to go do manual cleanup. On the other hand, it could just say, I don't care. Like, delete the user, fire it off, and if your message queue is robust enough, let's say one of those microservices died, the message queue would hold on to things, and there's a lot of message queues out there now that'll actually let every microservice that comes up say, hey, the last timestamp I retrieved a message from you was this, give me everything since then, so it can basically do a replay. And so you don't care that one of those services was down for 2 hours. When the email service starts back up, well, you probably do because emails didn't go up for 2 hours. But as far as deleting a user, it's going to come back up and go, give me everything from the last 2 hours. Oh, so-and-so got deleted, wipe out their emails, send my message out that says I deleted emails in case we want to put a green check mark on a board somewhere saying everything went well with this deletion. So you kind of have a really asynchronous method of letting them talk if you go with that do something, I did something mentality of your messages. But it's definitely not as easy as make a post request, get a response back, I'm done. So there's a lot of trade-off there. There's another question.
So speaking to that point, on the system on the left, how do you, if it doesn't seem like there's any persistent data store or any longevity, so what happens if one of the bottom microservices is down? Does the top microservice have to remember I need to keep asking this microservice to keep doing this thing forever? Does it have any way, is there any recovery mechanism?
I think that plays into why each microservice needs to have really good error handling. Because if one microservice does go down, the other microservices can't just fail unexpectedly. they need to return an appropriate status message that says, something failed because of this.
And since we keep talking about our unreleased product that nobody knows about anyway, I'll use Netflix as an example because people are more aware of it. So with Netflix, there are certain microservices that do things like look at your viewing history and pick out movies that would be good for you. But they have error handling in place that if that microservice goes down, and evidently, according to some of their talks and podcasts, it's actually gone down a lot, nobody even notices. Because all they do is either look in a cache, if they have it, if you've logged in recently, or if not, they just look at the general population in your area and have another microservice that they fall back on. And so basically you'd make a post request, and if you got back an unsatisfactory answer, you either have local cache of data, maybe you have some static data that says, okay, well, nothing's responding, so here's the 10 most popular movies today. Like, someone's hard-coded in a list of movies to give if everything else absolutely fails. And so microservices, one of the big parts of having all these moving parts and different pieces is making them resilient, making it so that if one piece falls out, your whole system doesn't crumble. Because otherwise, you really just have a many process monolith at that point. If you can't have one piece gracefully degrade, then you're not getting a lot of the benefits of the microservice architecture.
Plan for failure.
Yes.
Well, I guess, so on the system on the left, in this case of this cascading deletion system, it doesn't seem like there's any database, it doesn't seem like there's any persistence. So if, say, one of those subsystems died and was down, and then the top system, after 3 hours, never got a chance to, it kept asking, but it never got a chance, and then it just gets rebooted, say, then this user now is permanently 2/3 deleted state with no, and you'd never know.
Right, so this is the current structure we have. Each microservice has its own, technically database, it's a schema actually. They each have their own data, and we don't have a multi-microservice transaction model. So we either have to have good error handling that says, call these microservices in a specific order, and if something fails, don't, tell them to roll back or do something. But there is no good way, and I know we actually have a question submitted by one of our coworkers asking about transactions in microservices. So yes, there's definitely extra complexity there versus start transaction, do these 25 queries, and then either commit or roll back. And those are the trade-offs you make when looking at microservices for the robustness and the ease of redeployment versus a monolith where you kind of have that full control and that what you've been used to for a long time of it's all one big system.
With the architecture of, say, the application on the left, how do you handle data reconciliation?
I'm not sure I understand exactly what you're asking.
So let's say service on the left is user account, user profile, user purchase history. User deletes their account. One of the services was down, the second profile or whatever. Everything still completes successfully because the user account's gone and you can't find their history because the user's not there, but the data is still persistent. Data still right. How do you handle cleaning up all the orphan data?
That's similar to what he asked, kind of idea. We partially deleted this user, so how do we handle that?
Right, and so yeah, the answer to that is you either have to build a mechanism to do cleanup, to actually have a top level service that talks to these microservices again. It says, get only the good users and verify they exist, some sort of process to keep that. It's sort of like the difference between an ACID compliant database and a eventual consistency model. But on the other hand, you have an eventual consistency model here. The idea is, as long as you're making sure that from the top level, as long as that top microservice says the user's deleted, and now every request that comes in for a user gets stopped before you get to those bottom microservices. Now you're talking.
Yeah, you're potentially going to have to stay on the data,
right.
But it also doesn't matter unless that's all.
And you get into the idea of whether it should have been deleted or soft deleted, per practices. And if you have sensitive data and it's like when someone deletes something, it has to be wiped out, flat zeroed on the data and old records removed and history removed and sensitive data. Then you need to be careful with the architecture you're using and making sure that you have a model that says, when I get the request, go do that intensive cleanup and do not return back and mark something as done. In other words, don't remove that top record until I know everything else is done. Then remove it and send back. Otherwise, give the user an error and say, I couldn't remove your history, so I can't remove your account.
And so it's incumbent upon this guy
right.
to orchestrate that.
Right.
And so this scheme could get to be quite complex if they
right.
have to manage.
And then you have service dependency. your top level service can't remove said data if it's going to be.
Right, and that's just it. If you have that dependency as part of your model, you absolutely have to remove that data, or in the case of creating a user, if I can't create a profile, do I want to allow a user to be created? It's a question, it's a business question. It's what do you want your product to do?
And it's also an architecture question.
Right.
If that's a requirement, don't use that architecture.
Right,
If
well,
somebody
and,
else, like a message queue.
right, and so part of that is, you can have data that fails partially. You can have data that fails entirely on a request. You can say, 4 things happen, and if one of them fails, throw out the whole thing. Again, you can have as much dependency as you want. What you don't want is bidirectional dependency. You don't want the bottom one to be able to say, I want to remove a user record, and it has to go talk to the user now to verify something. You want to say, if it got to me, I assume the user is taken care of. Or if I have like document metadata, if I get a request for metadata, I assume the document information's already happened. Because the document thing should be asking me for the metadata. I shouldn't be asking it, what document does this metadata apply to?
Any other questions? So, how do you test a microservice, and how do you test its interaction with other microservices?
Want to tackle this one, Michael?
Man.
He's written a couple 100,000 lines of unit testing.
What have I been doing for the last 4 sprints? So we test everything, unit tests. We use Mocha to test the internals of all of our components inside of our microservices. And that's pretty good. We started a company-wide initiative to do what we call contract tests, but don't follow the definition of what contract tests are. So they'll
Because nomenclature is fun to break.
Yeah. So basically, when we're doing unit tests, we're testing the code, we're testing the functions directly. When we step up to contract tests, you kind of think automation tests, but not at the public level. So say you have, I'm not good at drawing pictures.
I'll draw it. I've drawn it for the team plenty of times.
There you go.
He draws very neatly.
We basically black box that specific microservice. So if you have like 4 microservices on your server and you're going to contract test that one, you are going to mock out the other microservice that it may come in contact with and just test the in and out functionality of that specific microservice. And then one step up would be the automation microservices, which would test the public API endpoints, which would literally go through your whole route. So it would go in and filter into every microservice that is required for the specific action that you're requesting. And because of that, we could be a little bit more lenient on unit testing, because if a unit test, you don't have to unit test every function, especially if it's a 4-line function that does one little thing. Yeah, I mean, that's over-engineering testing there. So if you have a contract test that tests the functionality, and that gives you a success case, then maybe your unit test only needs to test the error case of this specific function. As long as you're covering all the code, you're good. So yeah, there you go.
Unit test function, contract test the microservice standalone by itself, and then automated test the application as a black box.
And basically we've, our illustrious architect and some people related up there have put together a testing system that actually uses Mocha to run both our unit tests and our contract tests. So one of them works in the internals and actually stubs out part of the application and runs the function. The contract tests actually start up a copy of the microservice with stubbed out other services around it. So all the other services are black boxed and are mocked. And then it actually does a combined coverage report. We can look at, from Istanbul, the coverage tool. We can look at the combined coverage between our unit tests and our contract tests and not duplicate effort, not write a contract test that goes through 80% of the lines of code anyway, and then go unit test those same code again in unit tests when we already have a test that verifies they do what we want them to do. For the most part, if you can cover something at a higher level, it's better to cover it there than at a lower level. Some things you're never going to be able to test with a functional. You're never going to be able to write a test on the outside that easily says, what happens if the database returns a out of memory error? I don't want to fake turning my production database out of memory somehow. I want to do that at a contract level and put a stub, a mock database there and do that. Same thing with the unit test. I don't want to have to go write things at the unit test level that could have been tested at the contract level. So that's our name, contract, by the way. If you look up contract testing, it's a whole different thing.
One of the tools, though, that we have recently found and are utilizing pretty heavily now is, because we write in Node, so if anyone out there is Node, Rewire. I highly recommend looking at that if you're doing Node unit testing.
And it lets you do very easy mocks in your code because of the fact that JavaScript does not really have private anything. Things are public or not as public.
Yep. Alright, can microservices be libraries?
I like this question.
Good.
I'm glad, Joe. Have fun.
That's all I have to say.
I think you can think of microservices as libraries. They don't have to be, I don't think they have to be looked at as libraries, but to me, when I think of a microservice, I think of it as a library with an HTTP interface. The functionality is exposed over whatever protocol you decide to communicate on, and the functionality is whatever endpoint you have created. So for the most part, I think we have a couple microservices that are just thin wrappers around a specific library, one being our Validate library that we made. So yes, I think you can think of microservices as libraries. They're not exactly libraries in the sense that you import them into your project, more so you communicate to them from your project.
So a library traditionally is a piece of code that is actually in process running with the application you're writing. Microservices are the functional equivalent of that while being the technical opposite of that. You don't run something in process, you are a standalone running process that can fail independently, be run independently. So yeah, you can use them in the same way, but if you're running a microservice in process, you are doing something probably very wrong. I guess is the best way to say that.
But if you had a nice library that you like some Accusoft SDK that did some really cool image processing, you could certainly wrap that in some wrapper and run that inside of a microservice. So it could easily be encapsulated.
And I would guess we have some people in the audience that have done exactly that and made them available on the cloud for SDKs that were written a long time ago. And probably some people who wrote those SDKs in the crowd.
Would you ever use a monolithic architecture again?
I think as Stephen pointed out, that's never been a good answer. I mean, so monolith, yeah, historically it's always been how do we decompose these things. The move to microservices has really just been, and I think you touched on it with your question earlier, systems are fast. Communication is fast between microservices now. So you don't, it used to be you had to build it in a monolith because you had to have data transferred over a shared memory operation or something like that. You could not transfer things over TCP connections and have it be A, reliable, and B, fast. Now that that's not really the case anymore, I can't see building anything as a monolith that isn't so small that it really is just a monolithic, I mean, I could build something that's one microservice that I literally say I can't even decompose this because it's so small. We have lots of things like our build tools and some of our testing stuff that, I mean, it's just one piece of code because it's a couple hundred lines of code and does one thing. But if it's going to be a system of any complexity, anyone who was in Michael Pardue's presentation this morning on framing, that was kind of our first decomposition attempt. We broke down our node applications into components, which are essentially libraries. They're in-process pieces of code that were separated. And we still use that decomposition to get, so we can build maybe somewhat more robust microservices, bigger microservices, and touches on what Steven said. We have this one big one that we're trying to decide if it should be broken down, but it's already been broken down into 5 discrete components. And those run as in the same process, but they share a very similar interface to how a microservice would. So it's a matter of determining, do you want to build it in one process? Do you want multiple processes? If you're building something and you're not worried about scale, like you're, again, a deployed system, you're putting it on a user's desktop, so there's no chance a million users are going to use it. If you're talking web stuff, it's really hard to come up with a reason not to build something that's got the idea of horizontal scaling built into it. And we work entirely in the web. Now, at least.
And so I guess I recently have built a monolithic application, but I did separate it in the same way with these discrete components. So, I felt like it was not worth the effort to bring up multiple different processes for this small kind of utility. But the ideas were still there on how to separate it and how to break it down and how to keep each component independent and only communicate between components what's necessary to get the job done.
So one of the biggest differences between these monoliths and microservices, I mean, again, monoliths tend to be segmented anyway because it's good coding practice, but the independent deployability, independent testability comes in, and for something that's small and you're only using a couple components, it's not a big deal to say, go ahead and test my whole system and deploy a new one out. But if your deployment process, I'll talk back on ours, we had a deployment process that we had gotten up at one point to, we were we were doing microservices, but we were doing a single build that took all of our code from all our microservices and did one build. And it was getting up to the point where it took over 2 hours. And when we're trying to be on continuous integration, that sucks. So we did a lot of refactoring and redoing our build so that it independently built and got each one ready. And now we have a 2-minute build on a process and a 10-minute repackaging and a deployment to Amazon over a couple minutes. And from the time we commit code, we have about 15 minutes till it's out on the servers and is getting its final tests run. That's not something that's possible if they're all in process. If we have to build the entire application, we have to build the entire application. So.
Question?
Just to make a comment on reasons to build monolithic applications. If you have extreme need of shared access to memory, or shared access to disk, or shared access to specific hardware, like video games, or relational database, or nowadays they'd be considered more exotic type processing, but it used to be normal. Web stuff microservices were great, but if you need 100 threads banging against a single file in a single place, you're gonna have to use a traditional multi-threaded application.
And if you look at games, actually, that's a really good example of sort of a mix of the two, because most games, they have a core engine that's a monolith that runs, and then you'll notice if you ever do any scripting, plugins, UI work for games, you always have some sort of Lua, Python, some sort of scripting language on top of it, which is acting as a layer of services that can be deployed independently and run on top of it, and you have a single sort of service you're depending on that's the core. So you don't do everything in process, but you do all those things that are really time sensitive in process.
I was going to mention, if you're running on limited resources too, it might not make sense to have all the same boilerplate frameworks running. If you have like 3 or 4 microservices and you don't have a lot of memory, you don't have a lot of processing power, it might just make more sense as one single application, one single thread with different components separately.
How would you handle transferring large amounts of data between 2 microservices, and should they be on the same server?
What a timely question. Anyone else want to go first?
Don't do that. Why would you want to do that?
Yeah, I think this comes down to the conversation that we're having about our microservice that we don't know whether or not we should break up or not. At that point, if we have to do that large transfer data, it may make sense for those 2 components to be within the same microservice so that you don't have to try to figure out how to pipe that from one service to the other. And what happens if one of those services goes down in the middle of the pipe? How do you recover from that? So I think the answer would be you'd want those things coupled inside the same.
Yeah, well,
unless I don't know, maybe it's akin to document processing, and you've got some gigantic document that's being something. One microservice is doing operation X on this document, and this other microservice is doing operation Y on this same document. And you really don't want to pass this document directly between those microservices. So maybe there's some other microservice that's this document management microservice that holds this document. And so each microservice goes to that other one to do some operation on that document. And so they're not passing it directly, but they're going to this third party that contains this massive amount of data. And they can share it that way.
Just comment on that. So actually, my company, we deal with a similar problem. So we deal with data that's 300 megabytes plus. And that's exactly what we do is we have a separate data storage services just from that instead of having to pass it.
Right. So we have an interesting analog. It's not really at the microservice talk, but at the sort of more server architecture talk. Where we have a product where when it's deployed in a single server environment, it uses local storage, and when we work a lot with documents and big images, sometimes doing compression of very large things. Everything's stored on the hard disk, and when we went to our cloud deployment and worked out that, we basically replaced that layer with something that used a shared cloud storage. So we were using Amazon's S3 rather than trying to shuffle things around between the hard drives of servers or having to lock ourselves to a single server. So utilizing the tools that are out there for sharing things across servers, doing something in a single data center and using network attached storage, those types of things can alleviate the issue of I have to pass this thing over HTTP from various servers. I can pass around a path to something that's on the network storage, and then if it goes through 4 or 5 microservices to get to where the actual processes is happening, I'm not actually piping 300 megabytes through all those microservices. I'm passing a string of here's the file name on the network attached storage, and the final one just goes, okay, attach there, get it, do the processing, put it back, and now pass the resulting file name back up to the originating microservice. So, as to whether or not they should be on the same server, if you're actually passing a large amount of data, that's much appreciated, especially on whoever's paying for your network bandwidth. However, there's negatives in that too, whereas if you have front-end service A that's very lightweight and back-end service B that's doing a lot of heavy processing, and you decide to spin up 10 or 12 more instances of B because you need it in order to get your all the work done. If you have your two A services that have B running on the same server and they're set to always talk to my server because that'll be faster, you now have 10 completely dead instances of B that nothing's talking to. And so now you have to necessarily scale out the pieces of your application that don't need to be scaled for any reason. So if you lock yourself into always talking on the same server, you kind of lock yourself in having to almost treat it as a monolith where you have to scale the whole application out, otherwise those backend services never get talked to. And we've done some discussion about how does that work, and can you have preferences and sort of a weighted round robin, and there's lots of discussion of good ways to do that, but the general idea is if you want to keep your communication on server, you kind of necessarily couple yourself.
Dylan asked, what's the difference between microservice architecture and a service-oriented architecture?
Microservice architecture is an extension of service-oriented architecture in the sense that the services that you break down are now just independently running instead of just blocked off from other code.
Yeah, one of the biggest things that's in the, again, there's no spec for microservices. There's lots of keywords that may or may not be implemented, but one of the most common ones is independently deployable, which wasn't always a core tenet of SOA.
Yeah.
You wanted to separate into functional, or I guess you'd say domain-oriented code. This is our users, this is our documents, this is our storage, this is our account histories. But you didn't really get to, I want to be able to redeploy this piece and update its interface without really touching the other ones. And so it's really a matter of how much you wanted to be able to deploy things to independent servers and how small you make them. I mean, microservices just in practice, and that this may just be because the technology has improved and so we can do more communication. The standard of what a microservice architecture looks like is usually much smaller units than what SOA 10 years ago would have looked like.
Thinking about SOA leads to good thoughts about microservices, though. So it's the same, the same kind of questions that I ask myself when I'm thinking how should a microservice be split up, that we were asking how should we design this SOA product. So it seems like a very similar mindset, just with the idea that it should be independently deployable and it might have its own database. It's an extension.
And so all the way back to the beginning when we defined microservices, like I said, it's not a standard that was set. It was, people were already doing it. They were doing SOA and breaking things down smaller and trying to get them independently deployable and trying to make them language agnostic so they could talk over a specific protocol. And they all went, okay, let's come up with a name for this. It's microservice architecture now. So it really is just the evolution of SOA.
What's the best way to communicate between microservices, HTTP versus RPC?
Sorry, Samantha, could you repeat the question, please?
Oh, yeah. What's the best way to communicate between microservices, specifically HTTP versus RPC?
Thank you.
Go first?
I like HTTP.
Yeah,
Everybody knows HTTP.
Yeah, that's kind of
It's been the standard forever.
Language of the internet.
Yeah.
There's extra overhead, especially if you're serializing things. If you have binary data, you're having to add extra headers and do extra padding. If you're trying to do, unfortunately with REST, if you're trying to do both binary and metadata, then you have to encode your binary data because you don't want to do multi-part because that's not RESTful. So there's some caveats there, but in the general sense for passing information around, again, it's what is out there. It's what people expect things to work like. RESTful interfaces are very common, and so it's usually a pretty good, safe solution unless you can come up with a counter argument as to why, for your particular case, RESTful is not good. It usually makes a good starting point to look there. If there's special cases and you can come up with a counter argument or a reason why a RESTful interface is not going to be effective, And again, there are no set in stone rules. I mean, whatever's going to work for your product's going to work, but HTTP is probably a really good baseline to try to disprove before you start trying to reinvent the wheel.
And it kind of encourages you to keep the payloads using IDs instead of sending around 300 megabyte documents like that.
A couple minutes, then we'll let Jerry start hooking up his computer. So.
Alright, our last question was how do you do cross microservice transactions?
So we've actually kind of started this with an initiative inside of our company where we've kind of made a common service framework for our microservices. In fact, that's the name of the framework. But the idea is that when a request comes in over REST, we start a task for that request, and through the headers, as we pass that request down to different microservices, those headers keep track of the task which was started for it. And then made with some good toolings, some good tools that are made by one of our architects up there, we can actually visualize the path a request took and what microservices it hit and what paths it went in on, and basically keep the whole life of it, of the whole transaction, and know exactly where it's going and what it's doing, which becomes very beneficial when we're trying to troubleshoot problems to see where things are breaking and where in the line.
Yeah, and so that gets into how we kind of trace and log through them as far as a transactional model, being able to roll back or cancel a mid-process transaction. It really boils down to which of these you're doing. So if you're using sort of a model where you have a message queue, you're kind of automatically saying you're going to have eventual consistency. That's the basis of that model, and so you don't really have transactional consistency. Using a model where you're doing like these RESTful calls or these direct RPC calls, you do have the ability to do that. The unfortunate part is you have to manage it independently. Each microservice has to have its own transaction that it starts, and then it knows what else has to happen, and then if it gets the signal to say the transaction is complete, it resolves it, otherwise they all roll themselves back. It leads to a lot of coupling, so it's a dangerous place to go into there. Unless you have just, if you have a single straight line down of A calls B calls C, you can roll it down and then roll the transactions back up. If you have A calls B and C and D, it's dangerous for them each to have to be aware of some sort of signal that D failed, so roll back your code, because you're introducing a lot of coupling that really shouldn't be there at that point. I think we're going to get pulled off with the hook here in a second.
Please take the next 5 minutes.
Well, that was our last question. So Accusoft is hiring. So,
in case you haven't heard that 8 or 9 times today.
Got some perks up there with marketing sales.
Any questions?
We're going to talk about Jerry's